So yesterday you looked at a video to solve some quadratic equations, and the focus was on ones but had to equal 0, so you were looking for the x-intercept. Today we're going to solve equations that don't equal 0, and we're still going to use graphs to do that. So starting with example 1, we have x squared minus 6x plus 4 equals -4. And we're going to solve that by graphing. So we're going to take the left side here, and we're going to graph the equivalent function to go with it. So here's my equivalent function, this red one here, y equals x squared minus 6x plus 4. And in order to figure out where it equals -4, we're also going to graph the line y equals -4. So essentially we've graphed the left side of the equal sign from our equation and the right side. So these are the two equivalent pieces, and we're looking for where they are the same. So you'll notice that using Desmos is really handy because it'll actually highlight for you what those points are, where they intersect. So those are our two solutions. And notice that when you're looking at this equation here, there's no y, right? It's just x's. So the x values are what we are looking for. So we can see here the x value is 2, and here the x value is 4. So we get two solutions to this equation. So we can say x equals 2 and 4. So those are your two different solutions there. Example 2, this one we're going to use an actual context question. So a rectangle has dimensions 3x plus 1 and 2x minus 5. And we need it to have the area 1,150 square centimeters. What are the actual dimensions is what we want to know. So here we've been given a picture of what that looks like. And we know we're looking at area. So that means I need to create a model that represents the area. So we're going to let A, sorry, I must still be in the frame of the image here. Let A represent the area in square centimeters. Or we're always being specific when we define a variable. I don't really need to define x because it's already kind of done in the question and doesn't have a specific meaning. So then that means we're representing area as length times width. Which in this case we know is 3x plus 1 times 2x minus 5. And in fact, we're given in the question that the area is 1,150. So we now know the equation that we're actually looking to solve. There we go. Okay, so this is what we're going to use in our graph to actually find our answer. So this time it's in intercept form, but that doesn't matter. Plus 1 and 2x minus 5. Oops. And we're looking for where it will be 1,150. Notice we can't see it on the screen here. And we can easily change that by changing the window that we can see. so that now it's actually appearing on our screen. And you can see that we get two solutions again. And notice it's not always going to be whole numbers, and that's okay. Especially in context, we can give answers that are rounded, that are appropriate to our context. But here we have to realize that it actually does not make sense to have a negative solution since we're dealing with something that is an area. And if we were to plug negative 12 in here, we would actually end up with negative lengths and widths. So that doesn't make sense. We know that we need the lengths and the widths to be positive. So this answer 15 probably makes more sense. Let's just double check that. So if we did 3 times 15 plus 1, we're going to get something that's greater than 0, so that's fine. And then for the width, 2 times 15 minus 5 is also greater than 0. So 15 seems to make sense as an answer. So according to our graph, we know that x equals 15 because we've dismissed the other solution. Oops. Right, we can even just use 1 as an example. So 3 times negative 12.8 plus 1 would be less than 0. So we know right away that x cannot be the negative 12.8, but that it will be x equals 15. So therefore, the dimensions are, so remember we're going to answer the question asked. So actually we didn't even need to do the greater than 0 part. We need to know the actual values. So 3 times 15 is 45, plus 1 is 46. And 2 times 15 is 30, minus 5 is 25. And we know that the area is in centimeters squared, so this length and width must be in centimeters. And there you have it.